Lecture I am going to discuss on transformation of the independent variable. If you recall, in the previous lecture I said the continuous time signal is denoted by x of t and the discrete time signal is denoted by x of n. Here t is the independent variable in a continuous time signal and n is the okay, and n is the again independent variable in discrete time signal. Now let us look at how these independent variables are transformed. Okay, so there are three types of transformation that we will discuss. Before I enter into this topic, let me take one example, couple of examples. Okay, a central concept in signal and system analysis is that of the transformation of a signal. Okay, for example, in an aircraft control system, the pilot wants to take some action. Okay, so whatever he wants to do, his action, the actions of the pilot are transformed into electrical signal, transformed to electrical systems and mechanical systems. Okay, so in turn you can change the aircraft thrust, okay, or the position through this mechanical and electrical systems. You can control the thrust of the aircraft or position of the aircraft control surfaces. Okay, such as the rudder or ailerons. Okay, and again from this, which in turn are transformed through dynamics and kinematics. Of the vehicle into changes in aircraft velocity and heading, so that you can change the velocity of the aircraft, also the direction of the vehicle heading, in which direction it has to go. Okay, so this is one example, and the second example is, suppose you have high fidelity audio system. Okay, so the input to the audio system is through a recorded is through a cassette or a compact disc. Okay, you have cassette player or CD player, so the input is coming from this guy. Okay, the input signal representing music. Okay, so the cassette output is music signal, and from the CD also the output is music signal, and that is given to the high fidelity audio system. So the job of the high fidelity audio system is enhance the desirable characteristics. Okay, like it has to remove the noise, recording noise, and sometimes balance the several components of the signal like treble and bass, treble and bass. Okay. So therefore, the transformation of independent variable plays a central role. Therefore, in this lecture we focus on a very limited but important class of elementary signal transformations that involve simple modification of the independent variable, that is the time axis. On the time axis, what are the modifications that can be done? Okay, and also we will see in the subsequent lectures these elementary transformations allow us to introduce several basic properties of signals and systems. Okay, and later in a later point of time we will find that they also play an important role in defining and characterizing far richer and important class of systems. So let me start. Examples of transformations of the independent variable. So there are three types of transformations. Three types of transformations of independent variable. Here T is the independent variable of a signal. The first one is a simple and very important example of transforming the independent variable of a signal is a time shifter. You shift the signal either to the right or to the left. So this is the first simple operation that is done to the signal. Okay, a time shift in discrete time signal we will consider because that is easy to understand than in the continuous time case. So therefore, let me insert a figure, pictures, yeah. Let me take this figure. The x axis is n, and where n takes discrete values. Okay, let us say 1, 2, 3, 4 and so on so forth. So this point is 0, this one is 1, 2, 3, 4, 5, 6 and so on, and in this side this one is -1, this one is -2, this one is -3, this one is -4, this point is -5 and this point is -6. Let us say this amplitude is 1 volt. Since it is let us assume this is a voltage signal. So at n equal to -6 you have 1 volt, then 2 volt, 3 volt, this one is 4 volt, 5 volt, 6 volt, and let us say this is 7 volt. So this all are 7 volts, and again here it has 6 volts, 5 volts, 4 volts, 3 volt, maybe something very less, it's maybe 1.5 volts, something like that. Okay, so let us say 6 let us say 6 volt, this is maybe roughly 5 point something like that. So this is going to be, now it is coming very drastically. Anyway, that doesn't matter how much voltage it is. Okay. Now this is a typical discrete time signal. At discrete points, the point is not this voltage. The point is here it has value at a discrete points in the x axis. When n equal to 1 you have the signal, when n equal to 2 you have this signal, but in between you do not have any values. That is what we mean by discrete time signal. Now what I am going to do, I am going to shift the signal to the right. Okay. When you shift the signal to the right, see originally the signal was this one, and you are shifting the signal by n naught time units. That n naught time units can be 3 or 4 or 5 or 100, does not matter. When you shift the signal, the shape does not change, only the signal is translated into some other place on the time axis. That is the important point that you should remember. Okay, so the shape is preserved, but that are displaced or shifted relative to each other. Okay, we will also encounter time shifts in continuous time also. Okay, so for that let me consider another figure. Before, let me take one simple example. Let me draw here. So I have 4 signals. Let's see, like this. Let's say this is 1 volt, this is 2 volt, this is 3 volt. No, sorry. Let's say this is 1 volt, 2 volt, 3 volts and 4 volt. N equal to 0, 1, 2, 3. That's it. This time axis, and rest of the places it has 0 value. At -1 the value is 0, at -2 the value is 0, at -3 the value is 0, and so on so forth. And here also this is 0, 3, 4, 5 like this. Now let me call this signal x of n. I put a square bracket, and if I want to delay by 1 unit, then what happens? This entire signal shifted to the right. Okay, so here I have 4 volt. At n equal to 2, I have 3 volt. N equal to 3, I have 2 volt. N equal to 4, I have 1 volt. So this is 0, 1, 2, 3, 4. This all are zeros, and this side also as it is 0. At 0 also it becomes 0. So therefore what happens? The signal shifted to the right. Okay, and this operation is called a delay operation. This is called a delay operation by 1 unit. So how do you write this operation? X of n minus 1. Similarly, I can shift the signal to the right also by 2 units. Maybe I can do like this: -2, -1, 0, 1, 2, 3 like this. Then let me have 4 volts here, then 3 volts, 2 volts and 1 volts. Now the signal x of n is shifted to the left, and this operation is called advanced operation. Okay, you can also write this advanced operation as x of n plus 1 like this. So whenever you put +1 here, then it indicates advanced operation, and if you put -1, then it indicates delayed operation. And in another way also you can construct this, but let me take the same example. Originally at 0 it is 4 volts, then 3 volts, 2 volts, and let us say 1 volt like this: 1, 2, 3 and 0. So this is my signal, let us say x of n. Okay. Now I need to delay the signal by 1 unit. Let me call y of n is equal to x of n minus 1. I don't know whether it is moving left hand side or right hand side. Let me plot how it looks. Now what you do is start from 0, substitute n equal to 0 in this equation. So you get y of 0, which is x of 0 minus 1, which is x of minus 1. What is x of minus 1 in this figure? It is 0. Therefore this is 0. Therefore y of 0 equal to y of 0 is equal to 0. Similarly, you can substitute n equal to -1, n equal to -2 like that. You can check, you can substitute and you can check it out. Let us say n equal to -1, then minus, let me write properly, n equal to -1, then y of -1 is equal to x of -1 minus 1, which is x of -2. Again this is 0. From the figure you can see it is 0. So y of -1 equal to 0 is equal to 0. And again, if you substitute n equal to minus 2, then it is useless to do this operation. Now let us move to the right hand side. Now substitute n equal to plus 1. Then what will happen? Your y of 1 is equal to x of 1 minus 1, which is x of 0. At 0, what is the strength? It is 4. So it is 4 volts. Therefore y of 1 is equal to 4 volts. Now substitute n is equal to 2, then y of 2 is equal to x of 2 minus 1, which is x of 1. At 1, when n equal to 1, x of 1, the value is 3. So it is 3 volts. Y of 2 is equal to 3 volts. Now you put n equal to 3, then y of 3 is equal to x of 3 minus 1, that is x of 2. What is x of 2? At x of 2, the voltage is 2 volts. Therefore it is 2 volts. Y of 3 equal to 3 volts. Now then substitute n equal to 4, then y of 4 is equal to x of 4 minus 1, that is 3. What is x of 3? The value is 1 volt. So it is going to be 1 volt. Now put n equal to 5. Then what will happen? What is going to happen? Y of 5 is equal to x of 5 minus 1, that is 4. If you look at this figure, at 4 the value is, it is from 4 onwards, it is 0. Therefore y of 5 equal to 0. So we got different values of y. So what is your y of n? Y of n is equal to x of n minus 1. Now you plot the values. This is y of n. Now when n equal to 0, y of 0, what is y of 0? 0. Therefore it is 0. When n equal to minus 1, what is y of minus 1? 0. Substitute if you again n equal to minus 2, then you will get 0. Therefore in the left hand side it is all are 0. Now when n is equal to 1, then where is it? When n equal to 1, it is here. When n equal to 1, this is the 4 volt. Therefore you get a 4 volt. When n is equal to 2, then you get 3 volts here. Okay, so 3 volts. When n equals 3, then you get 2 volt. And when n equals 4, you get 1 volt. When n equals 5, you get 0. When n equals 6, 0, 7, 0, and so on and so forth. Therefore this is my y of n. This y of n is time shifted version of my original signal x of n. So it is delayed by 1 unit. So this interval, you can ask me what is that interval. This interval can be 1 second, or it can be 1 millisecond, or 1 microsecond, or 1 nanosecond, or 1 hour, or whatever it could be. It does not matter. Okay. So but in between I do not have any values. That values are not defined. Okay, I do not have any value. There is no value in between 3 and 4. In between 4 and 5 I do not have value. I have value only at n equal to 4 or 5 or 6, only the integer values. So that is what we mean by delay. Or similarly you can plot like y of n is equal to x of n plus 1. The same way you substitute n equal to minus 1, minus 1, minus 2, minus 3, 0, plus 1, 2, 3, 4, like that. You substitute, you will get different values, and if you plot, the plot would have moved to the left hand side. Let me take one more example for this delay operation for the continuous time cases. Insert pictures, then yes. So these figures, by the way, I took from Signals and Systems, by Alan V. Oppenheim, Alan S. Wilsky with Hamid Nawab. Okay. Now this is my original signal. This is the original signal, and this one is time. It is a continuous time axis, and this is x of t. Now I am moving the signal to the left hand side. Here I am assuming that t naught is less than 0. Therefore, it is x of t minus it is less than 0 means let us say minus 4 or minus 3 something. So, if you put minus 4, then it is going to be x of t plus 4. Therefore, the signal is moved to the left hand side by 4 units, and this operation is called advancement operation. Advanced. And this one is a delay. And this is advanced. So this x of t minus t naught is the advanced version of x of t. X of t. It's very simple to understand this. Delay means what? You are asked to do a job, but due to some situation, you may postpone the work. So that is called a delay. And you will know that you are going to do some work, but without asking that you are going to do that work. So that is called advanced. So advanced preparation. Okay, before the start of the class, you prepare something that is called advanced preparation. So this signal moves to the left hand side, then that is called advanced operation. That means before coming to its place, it is happening by t naught units. Actually supposed to occur at this point, but it is occurring little earlier. So this is the advanced operation. So such that are related in this fashion, like advanced operation or delayed operation, arise in applications such as radar. We use a delayed version of the signal or advanced version of the signal in radar and sonar applications, and seismic signal processing. Okay, so these are the 3 places where we can use this kind of operations. In fact, there are many, but it is some example. Okay, so in this 3 thing, several receivers at different locations observe a signal being transmitted through a medium like water or rock or air. Okay, so in this case, the difference in propagation time from the point of origin of the transmitted signal to any 2 receivers results in a time shift between the signals at the 2 receivers. So there the time delayed version of the signal arises to the receiver from the sensors. So this is the first type of operations. So time shift. So under time shift we have advanced operation and delayed operation. If advanced means x of let us say t plus t naught, delayed means x of t minus t naught. Okay, so that's it. Now let us move on to the second type of transformation, and this is also very important, and this one is called time reversal. It is very simple operation. Okay, so second basic transformation of the time axis is that of time reversal. Okay, so it is best to explain this with a figure. So let me insert a figure. Pictures. Where is it? I think Okay. Now this is x of n, original signal x of n, and this is your time axis. Now if you fold the signal, then that operation is called a time reversal. Okay. So the time reversal of x of n is denoted by x of minus n. Okay. And this x of minus n is obtained from the signal x of n by reflection about n equal to 0. So this is n equal to 0, you just reflect. So whatever occurs at n equal to 1, that is going to occur at n equal to minus 1. Whatever occurs at, maybe let me enlarge the thing. This point is 0, 0, and this point is 1, this point is 2, 3, 4, 5, 6, 7, 8, like this. Okay. Now maybe if you, then it would be easier like this to see. Now look at now. Now at 0, whatever there is 0, that same thing occurs at, and in this point is 0, no change, reflection. Now at 1, this is the amplitude, but that amplitude occurs at this point here at minus 1. So whatever the signal you have at 1, that is going to occur at minus 1 with the same amplitude. Let us say this amplitude is V1, and that V1 occurs here. Now at n equal to 2, the amplitude is V2, and that is going to occur at this point n equal to minus 2. Sorry, this is 1, and I am sorry, I marked mistake wrongly. Okay. This is minus 1 and this is minus 2, n is equal to minus 2. So therefore this point indicates V2. Now at n equal to 3, this point, no, this point is n equal to 3, and corresponding voltage is this voltage V3, and that V3 occurs here, and so on and so forth. And this point is n is equal to minus 3. So whatever occurs at n is equal to minus n is equal to plus 3, that is going to occur at n is equal to minus 3. Okay, and the corresponding voltage. Similarly, if you look at the negative side, when n is equal to minus 1, let us say the value is V minus 1, and that value occurs here V minus 1 when n equals plus 1, this point. And n equals minus 2, the corresponding value, let us say V minus 2, and that occurs here V minus 2, but the position is at 2. So this type of operation is called a reflection, time reversal. Okay, you are doing the reflection about n equal to 0, okay, by reversing the signal. So reflection means reversing the signal. Okay, that's all about time reversal. The same example let me consider. Once again, when n equal to 0, let us say 4 volts, when n equal to 1, let us say 3 volts, 2 volts, 3, 1 volt, 2 volts, like this. Let us say this is my x of n. What is the time reversal of x of n? X of minus n. So therefore you can apply the same concept, like let y of n is equal to x of minus n. Now substitute n equal to 0, then y of 0 is equal to x of minus 0 is the same as x of 0, that is 4 volts. Substitute n equal to minus 1, n is equal to minus 1, then y of minus 1 is equal to x of, already you have minus and again put minus 1, then it is equal to x of 1. So what is x of 1? X of 1 is 3 volts, right? Then substitute n equal to minus 2, then y of minus 2 is equal to x of minus times minus, it becomes plus 2, x of minus 2 is x of 2 is equal to 2 volts. Substitute n is equal to minus 3, then y of minus 3 is equal to x of plus 3, which is 1 volt. Now substitute n is equal to plus 1, then what will happen? Y of 1 is equal to x of, you have minus of 1, so minus 1. What is x of minus 1 in this? At minus 1 you have 0. Then y of 2 is equal to x of minus 2. What is x of minus 2 in the plot? 0 volts. Then y of 3 also again x of minus 3. If you look at the plot here at minus 3, it keep on goes up to infinity, okay, 0 volt, 0 volt, 0 volt, like that. Therefore 0. So now you got all the values. Now you can plot this. Let's say this is y of n. When n equal to 0, you have 4 volts. When n equal to 1, 0 volts. When n equal to 2, again 0 volts, 3 0 volts, 4 0 volts, and so on so forth to the right. Now on the other hand, when n is equal to minus 1, then what is the magnitude? 3 volts. When n is equal to minus 2, what is the signal amplitude? 2 volts. Then when n equal to minus 3, it is 1 volt. Now if you compare this figure and that figure, at n equal to 0, the same value occurs here and here. Whatever happens at n equal to 1, that is happening here. N equal to 1, the voltage is 3 volts. At n equal to 2, the magnitude is 2 volts, but now it occurs at n equal to minus 2 and it becomes 2 volts. And n equal to 3, it is 1 volt, and this is 1 volt, which occurs now at minus 3. So this type of operation is called a time reversal. Now let me consider one more example for this operation. Insert pictures. Which one is that? This operation, this signal. Now it is a continuous time signal, and this is time axis, continuous time parameter, and this one is x of t, and this is 0. Now the same signal, it's flipped over now about t equal to 0, and this is x of minus t. So whatever this shape, and this shape with the same distance in the left hand side. Let's say this point is 5 and this occurs at minus 5. Let's say this value is 1. Whatever occurs at 1, now it is occurring at minus 1. When t equal to minus 1, it's not volt 1. T equal to, let's say, 1 second, then it is occurring at minus 1 second. Let's say this point is at minus 4, t equal to minus 4 seconds, and that is occurring at plus 4 seconds. Therefore, it is reversed with respect to t equal to 0. The reflection occurs about t equal to 0. Thus, if x of t represents an audio tape recording, let us assume x of t represents audio tape recording, then what is x of minus t? Then x of minus t is the same tape recording played backward, okay, not in the normal direction. So you are playing in the backward direction. Okay, so that's all about time reversal. And the third operation is called time scaling. So this is very, very important operation. Okay, so let me insert a figure for this in order to understand very clearly. Pictures. Yes. Originally my signal is like this. this is x of t, and it is a continuous time signal t, because at every point it has values. It is like this. Now the operation is denoted by x of 2t, and this one is x of t by 2. When I say 2t, let us say this point is plus 2 and this is minus 2, then it becomes 1 and minus 1, and this becomes 4 and minus 4. So this figure shows three signals. One is x of t, x of 2t, and x of t by 2, okay, that are related by a linear scale changes in the independent variable. So here independent variable is t, and what we are doing linear change in the scale, either 2 times t or t by 2. So it is a linear coefficient like y equal to mx, right? So m is the slope. Similarly, instead of m I have 2 here, and here I have 1 by 2. So it is linearly you are changing the scale of the independent random variable. Okay, if you again think of the example x of t as a tape recording, this one is say minus 2 seconds to plus 2 seconds, 4 seconds of tape recording. Then x of 2t is that recording played at twice the speed. You are playing at twice the speed. Suppose you have a song, and then song duration is, let us say, 4 minutes in the normal speed. Now if you increase the playback speed in your VLC media player by 2 times, then that song will be completed in 2 minutes. So that's what we mean by this. This operation is called compression. And if you slow down, then what will happen? This 4-minute song will be played by taking 8 minutes time. So it is takes very slowly you are playing. Okay, so that is called half the speed of the recording speed. Okay, it is often of interest to determine the effect of transforming the independent variable of a given signal x of t to obtain a signal of the form x of alpha t plus beta, and this beta indicates time shift to the right or to the left. If beta is positive greater than 0, then you are moving to the left, and beta is less than 0, then you are moving to the right. Left and right. And this alpha is a scaling parameter. If alpha is greater than 0, then you are compressing. This example for alpha is greater than 0, and this one is alpha is less than 0. Mod of alpha is less than 1, I am sorry, not less than, greater than 1, this is a less than 1, mod of 1, let us say, I am sorry, mod of alpha, not mod of 1. Let me write properly. Oh my god. Yeah. So this operation indicates where alpha is greater than 1, and here mod of alpha is less than 1. So before we generalize this, let me take one more simple example, and then we will come back. Take the same example, 0, 1, 2 and 3. At 0, it has a magnitude of 4 volts, 3 volts, 2 volts, 1 volt. This is n, and the rest of the places it is 0. Minus 1 0, at minus 2 it is 0, at minus 3 it is 0, and so on, so forth, dot dot dot. Let me call this signal is x of n. Now I would like to find out x of 2n. So how my x of 2n would be? So let me call my y of n is equal to x of 2n. Now you substitute the same concept that you are going to use repeatedly. Maybe in the initial time you may feel little difficult, but once you practice this many times, then by looking at you can see how the signal would be and whether will it be compressed or expanded or shifted to the right or shifted to the left, or it is time reversed or not reversed. All these things will come automatically. Now substitute n equal to 0, then y of 0 is equal to x of 0, that is 4 volts. Now n is equal to 1, then y of 1 is equal to, now that is a beauty, 2 times 1, already there is a 2 sitting here, so 2. What is x of 2? X of 2 is 2 volts. When n equal to 3, I am sorry, 2 I need to write, right? Y of 2. Y of 2. What is y of 2? X of 2 times 2, 4. What is x of 4? 0. Then n equal to 3. Then y of 3 is equal to x of 6. Again x of 6 equal to 0, right? So it keep on goes, all are 0. Similarly, you take in the left hand side. When n is equal to minus 1, then y of minus 1 is equal to x of minus 2. 2 times 1, 2 times of minus 1, minus 2. It is again 0, because at this point 0, here 0, here 0, here 0. Therefore this is 0, y of minus 1, y of minus 2, again this is 0. Now let me plot this signal. How does it look? When n equal to 0, no problem, you have 4 volts. When n equal to 1, now look at the beauty, it is 2 volts, not 3 volt. When n equal to 2, 0 volts, n equal to 3, 0 volts, n equal to 4, 0 volts, and here minus 1, 0, and n equals minus 2, 0 volts, n equal to minus 3, 0 volts. Now look at here, it is missing some values by when you are speeding up, then you are missing this guy, this value is missed up, and this value also missed up, okay, and this one is coming here, and this one is coming here, and this one is called y of n. This y of n equal to x of 2n. Okay, so this is the x of 2n. On the other hand, if you take x of n by 2, let us see what happens. Y of n is equal to x of n by 2. Here your alpha is less than 1. What is alpha value here? Alpha is equal to 0.5. 1 by 2 is 0.5, right? So therefore 0.5. Here alpha is equal to 0.5. Now let's see what happens. Substitute n is equal to 0, y of 0 is equal to x of 0, which is 4 volts. Then n is equal to 1, y of 1 equal to x of 1 by 2, that is x of 0.5. What is the value at n equal to 0.5? Look at this figure, this is n equal to 0.5. At 0.5, in between there is no value, it is 0. Okay, so you have the value only at n equal to n takes integer value. Therefore at 1/2 it is going to be 0. N is equal to 2, then y of 2 is equal to x of 1. What is x of 1? 3 volts. Again, if put to n equals 3, then y of 3, this is going to be x of 3 by 2. X of 3 by 2 is 1.5. 1.5 it is not defined. Its value is 0 volts. N equal to 4. Y of 4 is equal to x of 4 over 2, that is 2. X of 2 is 2 volts. N is equal to 5. Then y of 5 is equal to x of 5 by 2, that is 2.5. 2.5 is at n equals 2.5, then its value is 0. Then n equal to 6, y of 6 is equal to x of 3. What is x of 3? Which is 1 volts. Like this you can keep on calculate. And if you plot these values, it looks like this. When n is equal to 0, then you have 4 volts. When n is equal to 1, 0 volts. When n equal to 2, you have 3 volts. At 3, no value. At 4, it has 2 volts. At 5, no value. At 6, it is 1 volt. So this is your x of n by 2. This is your y of n. Y of n. That's it. So therefore the signal is expanded now. When you do the expanding operation, you are inserting zeros. See, the 0 is inserted here, and here also one 0 inserted, here also one 0, and here also you are inserting some zeros. On the other hand, when you compress, what are you doing? You are missing some values from here. Okay, you are not considering this 3, you are not considering this 1 volt. At n equals 3, at n equals 1, you are skipping this value. So that's what happening when you introduce alpha which is less than 1 or greater than 1. Okay, this is called a time scaling operation. Therefore, 3 types of operation we are doing on the independent variables. Let me take one more example on this. So please practice as many examples as possible, so that will help you a lot. Let me take a signal. The signal is 0 up to t equal to 0, t equals 0, then it jumps over here, and this amplitude is 1, and it is constant, it stays constant till t equals 1, and then t equals 2, it has a linear slope. So this is my t. Let me put a grid so that I can draw the picture very clearly. So constant value, and then it goes like this. So this is x of t. Now let us find out one by one. I want to find out x of t plus 1. As I said, if I substitute x of t plus 1, the signal is shifted to the left by 1 unit. Shifted to left by 1 unit. You can do like that, or you can substitute the values and you can find out. Let us say y1 of t is equal to x of t plus 1. Okay, so substitute t equal to 0, substitute some discrete values. Let us say this is minus 1, t equal to minus 1, y1 of minus 1 is equal to x of minus 1 plus 1, this is x of 0. At x of 0, what is the value? 1. So when I say t equals 0, then y of 0 is equal to x of 0 plus 1, x of 1. What is x of 1? When t equal to 1, again the value is 1. Then t equals 2, or let us say 1.5. Then no, let us say t equals 2. Sorry, I did not consider those 1. No, first let me consider 1. Then I will go to 1.5 or 2, something else. Then y of 1 is equal to x of 2, 1 plus 1, 2. Therefore, at 2, the value is 0. Now let me consider one more value, 0.5. Then y of 0.5 is equal to x of 1 plus 0.5, 1.5. At this is 1.5, and if you extend, this value is 0.5. So these are the typical values. Now you can plot the same thing here. Y of t is equal to x of t plus 1. Okay. Okay, now when t equal to minus 1, the value is 1. So let's say this point is minus 1, the value is 1. When t equal to 0, again the value is 1. So it is a constant function like this. Okay, when maybe I'll little more extend this. Sorry. Like this, it goes like that. This point is 1. When t equal to 1, the value is 0, it is coming here. When t equal to 0.5, it is 0.5. So at 0.5, it is 0.5. When t equals 0, it is 1, it is 1. When t is equal to minus 1, it is 1. So this value is 1. So the whole signal is shifted to the left now. So this operation is called advanced operation. Okay, so this is x of t plus 1. Now similarly you can find out x of minus t plus 1. So x of minus t plus 1, this is obtained by first you shift the signal x of t plus 1, then you do the reversal operation. Okay, that reversal operation is x of minus t plus 1. Now this one is like this, minus 1, 0 and 1, x of t plus 1, then you flip over. So what will happen? So this will be like this. This is x of minus t plus 1. This point is 1, this is 0, minus 1 and this is time axis, like that. Now I would like to find out now x of 3 by 2 t plus 1. How do you do this? You first find out x of, and this one is obtained by, first you find out x of t plus 1 shifting operation. First you have to do time delay or time advanced, and from that you scale the operation x of 3 by 2 t plus 1. Okay, so first this one is x of t plus 1. Now what you do is 3 by 2 plus 1, that is 1.5 times you are expanding now. Okay, so this point is minus 1 and oh, wait a minute, 3 by 2 times t plus 1. So this point is minus 1 and this point is plus 1 and this is 0 and this is t, right? Now what you do? You expand by the factor of 3 by 2. So you can simply substitute some values like y of t is equal to x of 3 by 2 t plus 1. Substitute t equal to 0, then y of 0 is equal to x of 1. Okay, and substitute t is equal to minus 1, then y of minus 1 becomes x of what is that, minus 3 by 2. Why minus is coming? Yeah, I am taking minus 1 here. Three by 2 plus 1. 3 by 2 means 1.5 minus 0.5. So this is x of minus 0.5. At minus 0.5 again the value is 1. So this is going to be 1. Now take t is equal to 2 by 3. Then what will happen? Let's say minus 2 by 3. Then y of minus 2 by 3. becomes x of 3 by 2 times 2 by 3 plus 1. So it becomes x of 2. Is that right? No, this I'm sorry, this please don't consider this. From x of t you find out x of t plus 1. What is x of t? X of t is like this. Let's say this is 1 and this is 2. This is x of t. Then x of t plus 1 will be like this. Let me call this is y1 of t. Okay, so this is my y1 of t. Now what will I do? I will replace y1 of t in time scale axis, like this is -1, 0 and this is 1. So let me draw this picture again. So this is y1 of t, -1, 0, plus 1. Now let me find out y of t is equal to y1 of 3 by 2t. Now if you do this exercise, then you will get it. Okay, so now you can substitute t equal to 0, t equal to -1, t equal to -2, like that you can substitute and you will get the value. For example, if you substitute t is equal to 0, then y of 0 is y1 of 0. Okay, so what is y1 of 0? It is, sorry, it is 1, the same value. Okay, now t is equal to -1, which is -3 by 2 means 1.5. What is 1.5? 1.5 is 1.5, and that 1.5, where is at this point? It is 0, right? Then t is equal to 2, -2, y of this is 1.5. No, let us say t equal to 1. T is equal to 1. Then t is equal to 2. Then y of 2 is equal to y1 of 3 by 2 times 2. 2 will get cancelled. Y of 3 and go on, it is 0. So keep on getting 0 values. Similarly, you substitute t is equal to 2 by 3. Then what happens? Y of 2 by 3 is equal to y1 of, already have 3 by 2 times 2 by 3. So which is y1 of 1. What is y1 of 1? This value is 0. It is 0. So you don't have any value beyond t is equal to 2 by 3. So the rightmost point is 2 by 3. If you substitute any value beyond 2 by 3, 2 by 3 is roughly some 0.666 something, right? So you don't get any value. One second. So that's it. So you stop up to this point. Similarly, in the negative side also you can do, like t is equal to -1, then same thing, this is +1, y of -1.5, -1.5 is 0. When substitute t is equal to -2, then y of -3, which is again 0, because if you look at in this figure, at -1.5 the value is 0, at -3 again the value is 0. So no need to go beyond minus 2. So, you substitute t is equal to plus 2 by minus 2 by 3. Then what happens? Y of minus 2 by 3 is equal to y1 of, already have 3 by 2 there, times 2 by 3, right? 3, 2 will get cancelled. So, y1 of, I have minus sign here, so therefore minus 1. At y1 of minus 1, this becomes here. Now, the same shape comes here. Now, what happens when this is my y of t. When t equals minus 2 by 3 here, this is minus 2 by 3. Let us say this point is minus 2 by 3. Whatever the value you have at minus 1, see here minus 1 is here, it becomes 1. So, whatever the value you have at minus 1, that comes correspondingly at minus 2 by 3. Okay. And whatever the value you have 0, the same value occurs at here also. So, when t equal to 0, y1 of 0 also 0. So, both are same. So, this value will not be shifted. Now, this point when t equals 1 in y1 of t, that becomes, where is it? It's here, y1 of 1. Whatever is happening at t equal to 1, the same thing happening at 2 by 3. Therefore, this point is 2 by 3. So, this is your y of t, which is y1 of what? 3 by 2 t plus 1. This one, y1 of 3 by 2 t plus 1. What is y1 of t? y1 of t is equal to x of t plus 1. Therefore, this is replaced by x of t should be replaced by t plus 1. Therefore, 3 by 2 t plus 1. That is all. So, x of 3 over 2 t plus 1 is obtained by, first you shift the signal x of t plus 1, from this you scale by 3 by 2. That is all about shifting operation. Okay, suppose that we would like to determine the effect of transforming the independent variable of a given signal x of t to obtain the signal of the form x of alpha t plus beta, where alpha and beta are given numbers, some constants. It can be positive or it can be negative, it can be integer, anything. Of course, if it is a discrete, then it should be a whole number. A systematic approach to doing this is first delay the signal or advance the signal. So, that is the first step. Okay. In accordance with the value of beta. Okay. If beta is greater than 0, then that operation is advanced operation, and if beta is less than 0, then it is delayed operation. Am I writing correctly? See, x of alpha t plus beta, if beta is greater than 0, yes, advanced. If beta is less than 0, delayed operation. Yes, this is correct. Let us say if beta is greater than 0 means what? It can be 1, 2, 3 and so on, or 0.5, 0.6 like that. Less than 0 means negative values, that is all. So, x of t minus 1 means to the right, delay operation. Right means delayed. X of t plus 1 means then here beta is greater than 0. So, it is a left shifting operation. It is called a advanced operation. That is all. And after that, perform the time scaling. Second one is time scaling. And the third operation what you do is time reversal, or you can do time reversal and you can do the time scaling, no problem. But the first step is very important. You have to first advance or delay, depends on the beta value. So in the time scaling, if alpha mod of alpha is less than 1, then the signal is linearly stretched. We have seen the example also for this. And if alpha is greater than 1, then the signal is linearly delayed, linearly compressed. That's it. So that's all about the transformation of independent random variable. Okay, so let me stop at this point. Thank you very much.